Now let's look at how to simplify radicals. In order to simplify radicals, you need to know the perfect squares. Here's the list of the first 15. 1, 4, 9, 16, 25, 36, 49, 64. Oh, I skipped 81, 100, 121, 144, 169, 196, and 225. There's 81. Okay, so let's look at example 1. I have the square root of 72. 72 is not in my list, but I find the largest perfect square that will go into 72 without a remainder, and that happens to be 36. 72 is the same as 36 times 2. Well, 36 is a perfect square, and it has a square root of 6, so the square root of 72 is 6 radical 2. Let's look at another one. The square root of 150. 150 is not a perfect square, but it will divide by 25 6 times. The square root of 25 is 5, so the square root of 150 is really 5 radical 6. Let's look at another one. The square root of 500. 500 is not a perfect square, but it divides by a perfect square. 100 5 times. The square root of 100 is 10, so the square root of 500 is really 10 radical 5. The square root of 99. 99 is not a perfect square, but it divides by a perfect square of 9 11 times. The square root of 9 is 3, so the answer is 3 radical 11. Now what happens if you throw a negative into the mix? Well, remember, negative 1 as a square root is equivalent to I. So to get rid of that negative sign, the first thing you do is pull out I. Now I have I times the square root of 32. 32 is not a perfect square, but it divides by 16 twice. The square root of 16 is 4, so its square root is 4i radical 2.